All right, so it's time to start. Go ahead and get into chapter 2. Okay, chapter 2 talks about functions and what we can do with functions. But before we can do that, we're going to have to get into some other ideas. So let's go ahead and get started here. So let's talk about functions. Okay, so 2.1, we first talk about domain. So domain basically is a set of the x values. Okay, and we're talking about, we have to talk about x and y, right? So talk about x values. That's these values here. Okay, 1, 2, 3, -1, -2, -3. And then range is the set of the y values. It's this way. Okay, and it gets confusing for some kids. Now, we're going to start off pretty simple, just going to be recognizing what our domain and what's our range. So if we want to find the domain, we say it's a set, and it's just going to be the x values. -3, 5, 0, and -6. So -3, well actually -6, -3, 0, and 5. Usually lowest number to the highest number. And then our range, also a set, we have 4, 7, -4, and 4. Now notice, -4 and 4 both are repeated, or 4s are repeated. So I'm just going to look at -4, 4, and 7. You would not write them twice. Okay, now we can do the same thing for domain here. It'd be -4, 0, 4, and 7. And then range would be my y values. 6, 7, 8, and 9 with the brackets. Okay, now what makes something a function? Okay, well, we have what's known as a function machine. It's not mathematical, it's just an idea. Okay, so this refers to something being a function in terms of x, which means the variables in the problem are x. Okay, but the way this works is this. If I take a bunch of x values, here's my x values, and let's say one is a 4. Then you put in the 4. It goes through the function machine, and it spits out a 7. Okay, this would be my y value. Okay, but if I plugged in, let's say, a 10, plug in the function machine, it comes out, and let's say it gives you -3. That also is a y value. So what we have so far is the 0.47 and 10, -3. Okay, so this just continues as you go. Plug in -8, and let's say it comes out -1. So then you'd have the point -8, -1. As long as this is a function machine, or a true function, the way it works functions is if I put a 4 in the machine again, it's going to spit out a 7. If I put a 10 in, it'll always spit out the -3. Okay? If we put a -8 in and it spits out a 3, then it's no longer a function because it cannot spit out a different number. Okay, so the actual idea about functions, you don't have to remember the rule or the actual definition, but for every x value, it has its own y value. You can never have two different y values going to the same x value. Okay, and that's just how functions will work. All right, so how do I tell if something's a function? Okay, so here are 4 examples. Okay, well, the whole idea is as I plug things in, I always get a different value. Okay, or I get the same value. So if you just start plugging in numbers for this, like 4, you'll get 4 out. If I put -4 in, I'll get 4 again. I put -8, I'll get 8. But I will never plug in a number in here and get a different number here. So this is a function. Okay. So this one, okay, same idea. Plug in a number. 2 times 3 is 6. 6 plus 5 is 11. I always get the square root of 11. Okay. And basically, because you always have the same number, so this is also a yes. Okay. Now, here you have y being squared. So what we have to do is solve for y. You notice these were already solved for y. So they were good. So to get this solved for y, you have to square root both sides. But the key is here that I would get a plus or minus 2x. And because if I put a 4 in, I'll get this. Well, let's just put a 1 in. 1 squared is 1. 1 times 4 is 4. Square root of 4 is plus or minus 2. Well, that's two different numbers. That would be saying, like, if I plug a 1 in, I get a 2. But if I plug 1 in, I get negative 2. This is not a function. Okay? Because I have two different answers here. I get a plus answer and minus answer. So here, absolute value of x is equal, or y is equal to x. Now this is the opposite of this one. The difference is where the absolute value. If I was to solve for y, I would get y is equal to x, or y is equal to negative x. That's what we learned last unit. Which means for every y, I get two different x values, which makes it not a function. Okay? All right, so that's a quick rundown on whether or not an equation is a function. So let's now talk about determine the domain of a function. So these are all functions, equations, and stuff. So in general, try and keep this short for you so you can understand we're going to have two look-fors. One is if I have an x on the bottom, something on top, or if you have an x and a square root. That is our two big things, okay? Now domain, remember, are all the x values. Now in this case, it's all the x values that give real y values. Okay, so I'm going to look for these two things. If neither one of those two things in, your domain is all numbers. X works all the time. Okay, so if you look here, notice no x's in denominators and no x in the square root. That's a regular number in the square root. That's okay. So this has a domain that is negative infinity to infinity, all real numbers. Neither one of these two look-fors are there. Okay, so let's look at the next one. Remember my look-fors. There's no square roots in. 5x over x plus 3. Okay, but there is an x on the bottom. Correct? So the key here is this. What makes this an issue? Well, remember, in this case, the bottom can never equal 0. So this piece right here cannot equal 0. Okay, if it does, it's undefined. So what we do is we take the bottom piece, set it equal to 0, and if x is negative 3, negative 3 plus 3 is 0, the bottom 0, that makes it an undefined term. Okay, you get undefined term. Undefined. Okay, so in essence, you cannot be negative 3. Okay, so what do we do? Well, to find my domain, if I say x can't be negative 3, that would be this, right? Open circle of 3, but it can be everything else. So my interval interval notation has to match this. So it'll be negative infinity to negative 3, open, and negative 3 to infinity. And basically, it's what makes the bottom 0. Okay, so let's look at the next one. X's on the top do not matter. All right, it's the X's on the bottom. So what we have to do first is factor. Remember I told you we want you to practice factoring. This is going to factor to x minus 6x plus 3. Now, what do I know? Well, we know that this number can't be 0, so x cannot equal 6, because that would make it 0. This one, x cannot be negative 3. Okay, so to find my domain, we're going to graph both of those. We're going to put both of those on. Here's negative 3, it can't be. Here's 6, it can't be. But it can be every other number. So it can be all of that. So my domain has to match this graph. So left to right, negative infinity to -3, open, union, -3 to 6, union, 6 to infinity. And that would be my domain. Okay, and that's how we deal with x's on the bottom. Okay, now the next problem, notice we have a square root. Now we're dealing over here. Now we're dealing with this up here. And remember, what you have, number in here has to be a positive value. Okay, so when we look at this, this has to be positive when you're done, or 0. So we're going to take this value, set it, what's inside, we're going to set it greater than or equal to 0. Okay, because it can be 0, you can take the square root of 0, 0. So we're going to solve this like we know how to solve. Move the 6 over, divide by 3. X is greater than or equal to -2. Which, if I was to graph that on this, that would be closed that way. So my interval notation has to match my graph. So it's going to be -2 to infinity. That's my domain. All those x values work. Anything not on this line would give me a negative inside here, which would be imaginary. Okay, all right. Now, notice I have one more. It's a little bit different. And what it is it's not only a square root, it's an x on the bottom. Now remember, this cannot be 0 at the bottom either. So this sets up almost the same, just a little bit different. We're going to take this piece, but instead of setting it greater than or equal to 0, we're just going to make it greater than 0 because it's not allowed to be 0 on the bottom, which would still give me the same greater than -2, but the difference is it's open instead of closed. And that makes the difference. If the square root's on the bottom, you set it greater than 0. If the square root's on the top, you take greater than or equal to 0. Okay? All right, so next part about functions is evaluating them. This is the last part of this little chapter. Okay, so in this part, we're going to evaluate a function. Now, I already talked about y and f of x are the same thing. Okay, f of x and g of x are the same thing, just a different terminology. Okay, so here we have a function, 3x squared minus x plus 4. Okay, so I've got all these ways. We're going to do every problem the exact same way, and we're going to simplify. Okay, where the last one being probably the most tricky. So here's what we're going to do. You're going to take this problem. I want to find g of 0, which means x needs to be 0. So what we're going to do is we're going to take this, and everywhere we see a parentheses, we're going to put a 0 in. And we're going to solve. So this all 0, that 0, which would be equal to 4. And you're done. Okay? So we do it again. You take a second. If you want to pause, try this one. It's going to be 3 times parentheses plus 4. Inside the parentheses is a 2. See, that's 4. 4 times 3 is 12. Minus 2 plus 4. So the whole thing is 10 plus 4 is 14. Simple as that. Okay, now what happens if I put a variable in? Well, if I put a number in, I'm going to get a number out. Now, we'll backtrack for a second. What do these numbers mean? It means when x is 0, y is 4. When x is 2, y is 14, and so forth. Now, what happens if x is 14? Well, we're going to do the same thing. 3 times something squared minus something plus 4. And all we're going to do is put 14 in. Okay, so that's going to be 16t squared minus 4t plus 4, which the only thing I can do is multiply that first piece. 48t squared minus 4t plus 4. Now, this is an expression, you leave it like this. Do not simplify. Nothing goes together. You cannot deal with it. Leave it as is. Okay. All right. So try the next one. See what you think. Okay. We plug in 2t squared. 2t squared. This is going to be 3 times 4t to the 4th minus 2t squared plus 4, which simplifies, or these two multiply. 12t to the 4th minus 2t squared plus 4. Even though they're all even, you do not reduce any of it. It is an expression. Expressions do not simplify farther. Okay? You can factor out a 2, but you have to leave it in the answer. Okay? That's too much work. All right, so the last problem. Now I'm going to find g of k minus 1. Okay? So it's still going to be 3 times parentheses minus parentheses plus 4, and now we're going to put in k minus 1. Now, careful with your signs. Okay, this here is k minus 1 times k minus 1, which is going to be k squared minus k plus 1. Okay, so it's going to be 3 times k squared minus 2k plus 1. And then be careful here. This is minus k, and then minus the minus 1 is plus 1 plus 4. Now this can simplify, but if by combining terms, 3k squared minus 6k plus 3 minus k plus 1 plus 4. So this is going to end up being 3k squared. Combine your k's together, that's 7k. And then 3 plus 1 is 4, plus 4 is 8. And there is my finished expression. Okay. Again, if they had something all in common, just leave it as is, or you factor the whole thing out, but you can't lose it. Okay. All right. So that is 2.1. I hope that helps. Okay. And good luck.